dial up on the phoropter to get back to neutralization.
Remember, with movement tells you to change sphere in the plus direction, to dial down on the phoropter. Against movement tells you to change sphere in the minus direction, to dial up on the phoropter. It's really very straightforward. So far, the examiner has remained at the normal working distance and has moved the far point about by changing the lenses in front of the eye. Once the far point is in the vicinity of the retinoscope, however, the zone of neutralization can be examined very precisely by moving forward and backward, like so. If you move forward inside the far point now falls beyond the retinoscope, and you will pick up with movement. The farther forward you move, the more pronounced the with movement becomes. By your moving back beyond the far point comes to fall between the phoropter and the retinoscope, and you'll pick up against movement. The farther you move back, the more pronounced the against movement becomes. As you move forward again, you'll move through the dead zone and pick up with movement once more. By this to and fro movement, you can exactly locate the front edge of the dead zone, where only minimal with movement remains. This is generally the best endpoint. With movement is easier to detect than against movement, and whether you move to the far point or bring the far point to the retinoscope with lenses, the best endpoint is leaving a little with movement. Now it's time to retinoscope an eye with an unknown spherical error. First, set the schematic eye to an unknown spherical value without looking at the scale. Then position yourself at the normal working distance and dim the lights. Be sure to hold the sleeve on the retinoscope up and look for with or against movement.
Here's with movement. That's easy. We dial down to add plus until just a little with movement remains. That's too far. Back one, and we're done. Here's another unknown spherical error. Now there's against movement to start with. The first thing to do here is to dial up. Go in the minus direction until we convert the against movement into definite with movement. Then we dial down as slowly as before until just minimal with movement remains. To be sure the endpoint is correct, we can move a few centimeters forward to see the increased with movement, and then a few centimeters backward, getting into the dead zone or even seeing a little against movement. This to and fro movement is the mark of a skilled retinoscopist. To be sure you are leaving the right amount of with movement, ask an experienced retinoscopist to check the appearance of the reflex. You should neutralize a series of unknown spherical errors in this way before proceeding further. That's all there is to neutralizing spherical refractive errors with retinoscopy. Unfortunately, there is such a thing as astigmatism, and practically all eyes have at least.
Creo que hay una señora muy miope. A ver. Ahí está. A ver. Muy brevemente esto.
You would probably appreciate the more obvious reflexes obtained with the pupil dilated. If dilating drops are used, the person can be instructed to look directly at the retinoscope light, with the other eye occluded. Now we'll neutralize each eye in turn. For the right eye, I see against movement initially, so I dial up to get with movement in all meridians. There, the against movement is gone. It is obvious that the 80° or so meridian is neutralizing first, so I concentrate on that meridian and change the sphere slowly in the plus direction to neutralize almost all the with movement. 90 degrees away, I find the maximum remaining with movement, and I enhance the reflex to locate the principal meridian. I place the minus cylinder perpendicular to the intercept.
No, hacia atrás, hacia atrás. Por favor. Más hacia el comienzo. A ver, hay un punto donde él se refiere a la posición que un poquito más atrás. A ver. No, más para adelante. Hay un momento donde él habla. Bueno. Un poquito más adelante. Bueno, de todas maneras, si no, yo se los explico. Es muy importante que el examen se haga, ¿sí?, a esta distancia. Y después hay que descontar una dioptría por ese motivo. A ver.
Ahí.
No, a ver, avanza un ratito más. A ver, antes de que empiece con la señora. Ahí, a ver, larga ahí.
Be as close to the patient's visual axis as possible for the best accuracy. And if the patient does not have strabismus, using the other eye for fixation is the best way to achieve the proper alignment. Retinoscoping off-axis more than 15 degrees introduces significant unwanted astigmatism. Keep both of your eyes open if possible. It's easier to do this if the room is quite dark. The best fixation target is a small light. A projected letter can stimulate accommodation, and large bright fixation targets produce annoying reflections in the corrective lenses.
There's no way to avoid entirely the reflections of the retinoscope light in the phoropter lenses, and one simply has to move slightly to one side or the other to see past the reflections. Should dilating grafts be used for retinoscopy? Probably not. The natural pupil is the one the patient ordinarily uses for seeing, and optical aberrations uncovered by dilating the pupil can cause confusing reflexes and even yield a different refraction. For starting out in retinoscopy, though, you would probably appreciate the more obvious reflexes obtained with the pupil dilated. If dilating grafts are used, the patient can be instructed to look directly at the retinoscope light, with the other eye occluded. Now we'll neutralize each eye in turn. For the right eye, I see against movement initially, so I dial up to get with movement and release.
Pero se lo busco o lo buscan ustedes mirándolo.
There, the against movement is gone. It is obvious that the 80 degree or so meridian is neutralizing first.
Cortamos acá con esto y pasamos a otro tema. Sería, creo que vienen cilindros cruzados. Sí, bueno, dentro de las mediciones subjetivas, que lógicamente están las clásicas, que son las que vamos a usar, ¿no?
Te juro que llegué y me congestioné.
Que son los clásicos optotipos, donde lo que tratamos de hacer es que el paciente reconozca la separación entre dos puntos, o sea, hablamos del poder resolvente del ojo. Podemos identificar que no hay una confusión entre lo que conforma una letra cuando los dos puntos que estamos tratando de observar caen sobre dos neuroreceptores separados por un tercero. Entonces, así como nosotros hablamos de octotipos, no sé si tendré algo de esto acá estamos hablando de una agudeza visual 20-20 o 10 décimos, ¿no es cierto?, cuando el arco mínimo es de 1 minuto, siempre decimos que es digamos, el ángulo mínimo de entrada que es percibido, ¿cierto?, por el ojo, sin que haya, digamos, una interferencia. Es decir, esto depende obviamente de la densidad de los fotorreceptores y de las interconexiones. Bueno, acá tocaría los cilindros cruzados. Vamos a interrumpir, córtelo un segundito acá. Entonces, digamos, hay muchas formas en que podemos encarar la refracción, digamos, las más simples, lógicamente, una vez que supongamos que solamente tenemos cristales y solamente tenemos alguna forma de medir la curvatura del globo ocular o de la córnea. Entonces, si nosotros ya sabemos que hay un cierto astigmatismo, pero supongamos que no tenemos ningún otro elemento que las lentes de la caja de prueba. Entonces, podemos, por ejemplo, suponiendo que nosotros intuimos si es miope, hipermétrope, por las características del ojo o por el anteojo que el paciente viene usando, ustedes podrían en principio empezar con -3, ir agregando, ¿no es cierto?, si es miope, y podrían estar usando el famoso test bicromático, que creo que todos ustedes conocen. El ojo es en realidad sumamente convergente y ya hemos visto que los distintos colores, por su longitud de onda, se cortan con el eje principal más adelante o más atrás. Más atrás el miope, más adelante el hipermétrope. Entonces, si nosotros estamos hablando ahora de que no tenemos ningún elemento más que la curvatura corneal, sabemos que hay un pequeño astigmatismo y lo que empezamos es a poner cristales, vamos aproximando, viendo el optotipo, hasta qué optotipo llega a ver, y vamos agregando cristales y de pronto ponemos el test bicromático y el paciente nos dice, veo mejor el rojo, ustedes saben que tienen que agregar más poder negativo. No, acá ya estoy viendo más claro el verde. Entonces, ustedes se han pasado y pueden volver atrás. Y para esto pueden usar, hay distintas combinaciones de lentes que se pueden girar fácilmente o anteponer, que pueden tener más 0,25 y menos 0,25 o más 0,50, y hacemos lo mismo que en la esquiascopía, vamos acercando y testeando. Obviamente es un método bastante elemental, pero digamos es un punto de partida que creo que estábamos hablando con los chicos que son de José Cepas, que ellos están usando en este momento en el sanatorio, en el hospital que ellos... Ahora, lógicamente, esto se puede perfeccionar de distintas maneras. Yo voy a tratar de mostrárselos en la práctica porque es más fácil. Y les voy a mostrar brevemente un método para afinar el eje del cilindro, más allá de la determinación de la topografía, porque el astigmatismo no tiene por qué coincidir con la topografía, que es el de los cilindros cruzados, que nos sirve para determinar el eje y para también establecer el monto del cilindro. Sobre esto no hay pregunta de examen porque es demasiado complicado, es mucho más fácil de interpretarlo prácticamente. De todas maneras, sí, ponemos el video.
Methods to estimate in the various ranges of refractive correction. Instruction manuals for his retinoscopes provide further explanation of these estimating methods. Before finishing, Dr. Guyton will take a look at common problems with the retinoscopic reflex, and will discuss what to do in each case.
Here we're retinoscoping a patient without drops, and suddenly the pupil constricts and the reflex changes.
No,
What happened? The patient looks directly at the retinoscope light.
ya así es.
Redirect his attention to the end of the room. That's better.
No, este es todavía retinoscopia. Sí, sí. Ahí está.
Which is better, 1 or 2? Now which is better, 3 or 4?
Subjective refraction, the procedure of using responses from the patient to determine the refractive correction for the eye. Trial and error or alternate choice techniques are applied in a step-by-step process, with those patients old enough and cooperative enough to respond, to arrive at the best optical correction. In the 19th century, subjective refraction was often performed with rotating discs of spherical lenses for the correction of myopia, hyperopia, or presbyopia. Astigmatism was more complicated to correct, however, and astigmatic dial targets were devised, First to locate the axis of astigmatism, and then to balance the refractive correction in the two principal meridians.
Todo no se
The
usa más.
astigmatic dials are still used by some refractionists, but they can be difficult for patients to understand. In 1887, Edward Jackson described a fixed-power Stokes lens that he'd recently added to his case of trial lenses. This astigmatic lens, used to refine the power of a cylindrical correction, was the forerunner of the Jackson cross-cylinder as we know it today. Jackson stated that this single lens had come to be far more useful and far more used than any other one lens in his trial set. Indeed, the Jackson cross-cylinder has become the world standard for accuracy in determining both the cylinder axis and cylinder power in subjective refraction. This program presents the basic theory and clinical steps of subjective refraction using cross-cylinder techniques, as demonstrated by Dr. David Guyton at the Wilmer Ophthalmological Institute of the Johns Hopkins University.
Subjective refraction begins with taking the visual acuity and ends with writing the prescription for glasses or contact lenses. We'll demonstrate the determination of sphere, cylinder, and axis, binocular balancing, and measurement for reading aids. Over-refraction techniques and cycloplegia will also be discussed. Before proceeding with the steps of subjective refraction, though, let's take a quick look at the basics of astigmatism and cross-cylinder testing.
Light from a point on a distant letter chart is shown entering an emmetropic eye and coming to focus on the retina. If the eye is astigmatic, the light will come to focus in two focal lines rather than in a single focal point. The focal lines are oriented in the principal meridians of the astigmatism, here shown horizontal and vertical. The focal lines can be moved forward or backward by adding spherical lenses to the eye, plus lenses to pull the focal lines forward, or minus lenses to move the focal lines
Es lo que
backward.
haríamos con los lentes, ¿no? Poniendo lentes
Diametrically midway between the two
aproximar,
focal
digamos,
lines is
el
the cross-section
resultado.
of the bundle of rays called the circle of least confusion. The spherical lens, which places the circle of least confusion on the retina, is called the spherical equivalent of the refractive correction. If the circle of least confusion falls on the retina, each point of the letter chart is equally blurred in all directions. But if the vertical focal line is placed on the retina, the vertical strokes of the letters become clear and the horizontal strokes become blurred. On the other hand, if the horizontal focal line is placed on the retina, the horizontal strokes of the letters become clear. It is important to adjust the sphere to place the circle of least confusion on the retina before testing with the cross-cylinder. This is done by trial and
Primero
error
es
adjustment of
buscar
the
el
sphere
círculo
for best
de
visual
menor
acuity.
confusión. Sí, que
With the
esté
focal
en
lines
algún
now
punto
straddling the
intermedio.
retina, the cross-cylinder is introduced with its axes aligned with the principal meridians of the eye's astigmatism. In this flip position 1, the plus cylinder, axis 180, pulls the horizontal focal line farther forward, and the minus cylinder, axis 90, lets the vertical focal line slide farther backward, increasing the amount of astigmatism and thus increasing the blur. The cross cylinder is then flipped to position 2, interchanging the plus and minus axes. Now the plus cylinder, axis 90, pulls the vertical focal line forward, and the minus cylinder, axis 180, lets the horizontal focal line slide backward, decreasing the astigmatism and decreasing the blur. Here's the patient's view of the letter chart as the examiner flips the cross cylinder and asks, which is better, 1 or 2? The patient chooses position 2. The cross cylinder is left in the preferred position, and the cylinder power is added in the orientation indicated by the axes of the cross cylinder. If plus cylinder is added, it is placed with axis 90. If minus cylinder is added, it is placed with axis 180. In either case, when cylinder power is added, only one focal line is moved. For example, if plus cylinder axis 90 is added, only the vertical focal line is pulled forward, and the circle of least confusion is pulled forward half as much off the retina. Before the cross-cylinder test is applied again, the circle of least confusion must be moved back to the retina. This is accomplished by changing the sphere half as
Cuando
much
se
as the
aplicó el
cylinder power
cilindro,
and
hay
in
que
the opposite direction.
buscar otra vez
For
el
example,
círculo
here
que
the
tiene
sphere
más
will be
confusión.
changed half as much as the cylinder in the minus direction to move both the focal lines backward and the circle of least confusion back to the retina. The desired result of cross-cylinder testing is neutralization of the astigmatism, with the focal lines collapsing into a point focus on the retina. Now, if the cross cylinder is introduced, astigmatism is created in flip position 1, but an equal and opposite amount of astigmatism is created in flip position 2. The patient sees flip positions 1 and 2 as equal, the desired balance between the two positions. Note that both positions are slightly blurred. When the cross cylinder is then removed, each point on the letter chart becomes a clear point focus on the retina. The strength of cross-cylinder testing lies in the two-choice balance between the two flip positions, an easy task for the patient. Now the circle of least confusion, or the point of best focus, must be maintained on the retina by proper sphere adjustment during cross-cylinder testing. Otherwise, problems can occur. For example, here's an eye that is slightly myopic, having a point focus anterior to the retina, with no astigmatism at all. Look what happens when the cross cylinder is added to check for astigmatism. In one position, the horizontal focal line falls on the retina, and in the flip position, the vertical focal line falls on the retina. The patient is asked, which is better, 1 or 2? 1 or 2? The patient will choose position 2, because more of the letters are recognizable when the vertical strokes are clear than when the horizontal strokes are clear. The patient will thus be given an astigmatic correction, whatever it takes, to place the vertical focal line on the retina. This is a known artifact of cross-cylinder testing with letter charts, and is avoided by frequent adjustment of sphere to keep the circle of least confusion, or the point of best focus, on the retina prior to and during cross-cylinder testing.
Those were the basics of astigmatism and cross-cylinder testing. We'll return to focal lines and to the circle of least confusion as we proceed through the steps of subjective refraction.
It is usually faster to refine an existing refraction than to start from zero power, so whenever possible, start with the previous correction, or with the retinoscopic finding. Most refractionists occlude the eye not being refracted, but some leave it open, blurred by plus lenses. Here, Dr. Guyton begins by occluding the left eye and taking an initial visual acuity for the right eye.
Now read the smallest line you can see on the chart.
A, P, S, O, T, F.
Good, now watch closely. I'm going to change it. Does this make it better or worse? Ready?
Sphere will be adjusted first for best visual acuity. Note that the instructions to the patient should follow a definite pattern and must be timed to the lens changes made. First, get the patient's attention. Say what will be done. Then ask the patient the appropriate question, stating alternative brief responses, such as, does this make it better or worse? Alert the patient to the change by saying, ready? Then say, there, as the change is made. Let's watch.
Good, now watch closely. I'm going to change it. Does this make it better or worse? Ready? There.
Notice that sphere is always changed first in the plus direction by dialing down on the sphere dial. This pulls the focal lines or focal point forward, tending to relax accommodation. How much of a change is made? This depends on the present level of vision. The change must be large enough for the patient to appreciate. With vision better than 20/40, quarter diopter changes are used, corresponding to one click of the sphere dial. With vision 20/40 to 20/80, half diopter changes are appropriate, 2 clicks on the dial. With vision worse than 20/80, 1 diopter changes may be necessary. The patient will respond to the first change in the plus direction by saying better, worse, or the same. If the response is better or the same, keep going in the plus direction.
Does this make it better or worse? Ready? There.
Better.
Good. Now is this still better or worse? Ready? There.
That's worse.
Good.
Notice that as soon as the patient said worse to continue change in the plus direction, the last change was canceled, completing the initial adjustment of sphere. If the response to the first change in the plus direction is worse, the change is not only canceled, but testing is then performed in the minus direction. Let's listen to the proper instructions.
Now watch closely. I'm going to change it. Does this make it better or worse? Ready? There.
That's worse.
Good. Now I'm going in the other direction. Does this make it better or just smaller and darker? Ready? There.
Better.
Good. Can you read farther down on the chart?
TZVEOL.
Fine. Now is this still better or just smaller and darker? Ready? There.
Just smaller and darker.
Good.
The first change in the plus direction made vision worse, so the plus change was removed. The first change in the minus direction made the vision better, as documented by the patient's reading smaller letters. The next change in the minus direction made the letters just smaller and darker, as happens when the patient begins to accommodate. This last change in the minus direction was therefore removed, and adjustment of the sphere was complete.
Ya terminó.
Let's watch this last sequence from the patient's view.
Now watch closely and I will change it. Does this make it better or
Últimos
worse?
momentos, ya lo libero.
There.
That's worse.
Okay, now I'm going in the other direction. Does this make it better or just smaller and darker? Ready? There.
Better.
Good. Can you read farther down on the chart?
Bueno, se hace un poquito
TZVEOL.
largo. Yo les voy a mostrar
Now, is this
prácticamente
still better or just
cómo lo
smaller and darker?
hacemos
Ready?
y qué rápido
Bien.
puede ser, porque acá está mostrando solamente el efecto de más o
When the
menos
sphere is
cilindro,
changed in
pero
the
se
minus
puede usar
direction, the letters may
formando
first become
diagonales,
smaller, darker, and clearer.
para ubicar el
Continuous
eje
change
correcto.
in the minus direction is made.
Ajá, Luz, por
The
favor.
letters do not become any
Les
clearer.
agradezco muchísimo la paciencia que nos han tenido en estas 2 horas. ¿Quieren hacerme alguna pregunta respecto de esto?
Muchas.
No, digamos, ustedes tienen acá una enorme oportunidad de mirar todo tranquilamente en su casa. Es muy, no digo fácil, muy ordenado, ¿no es cierto? Y esto es lo que me gustó de este último video, que no recordaba, que poner mucho énfasis en primero acercar la corrección esférica hasta encontrar el punto de mínima confusión. Pero ya teniendo el astigmatismo corneal medido con alguno de los métodos, ¿no? Ya uno tiene una pauta, porque es muy raro que, digamos, que haya un astigmatismo de 2, 3 dioptrías y que ese no se manifieste. Eso es muy, muy extraño. Puede ocurrir, puede haber alguna excepción, pero normalmente un astigmatismo corneal generalmente pues tiene una expresión en el cilindro. Y además, ustedes ya tienen más o menos la orientación. Entonces, después, con el sistema cilindro cruzado, como se los voy a mostrar en la clase práctica, pueden ir orientándose rápidamente hasta llegar a afinar, yo le diría, hasta 1 grado el cilindro. Yo generalmente me quedo en los 5 grados, porque además, después la realización con el anteojo, más allá de una precisión de 5 grados, no es muy frecuente, pero ya 5 grados, se puede llegar hasta 1 grado, fenómeno. Pero digamos, con 5 grados estamos bastante bien. Y después, lo que es muy importante es volver atrás y fijarse de que no hemos sobrecorregido, porque al poner el cilindro podemos habernos salido exactamente del círculo de mínima confusión. Y para los lentes de contacto, todo esto también tiene otra implicancia que la vamos a ver en la clase del jueves, cuando hablemos de selección de lentes y cómo los usamos y astigmatismos residuales. Muchísimas gracias y vayan anotándose las dudas para que después en la clase práctica las podamos. Ustedes están cansados.